So here are some examples of functions. Let's take some time to practice determining whether or not they are polynomial functions, and if they are polynomials, finding the degree and the leading coefficient. Question 1. We see that it is a sum and difference of terms. That's the first thing we need to look at. The second thing is we need to check all of the exponents on the variables. They need to be positive integers. Yes, this is a polynomial function. Why don't you find the degree and the leading coefficient? The highest exponent is the degree. The number multiplying the highest power of x is our leading coefficient. And what we are always going to be interested in when we're talking about degree is whether or not it's odd or even. In this case, it's odd. And with the leading coefficient, we want to know if it's positive or negative. This one is positive. Why don't you decide if the next one is a polynomial? Yes, it is. All of the exponents on x are positive integers, and there's no multiplication or division of x. It is a sum and difference of terms. Find the degree and the leading coefficient. The degree is 2. The leading coefficient is -6. The degree is even, and the leading coefficient is negative. What about the next one? Is it a polynomial? Well, I hope you know that this can be written as x to the power of 1/2, and 1/2 is not an integer. So no, this is not a polynomial function. What about the next one? Well, first of all, it's not a sum or difference of terms. It's the division. So we could also write this as x squared plus 8 all multiplied by x cubed plus 1 to the power of -1. Now I have an exponent that is not greater than or equal to 0. So again, no. In fact, this is a rational function, not a polynomial function. What about the next question? Is it a polynomial? The first thing you'd want to do is write it in standard form. Why don't you do so? Yes, all of the powers on x are positive integers. This is a polynomial function. Did you find the degree and the leading coefficient? The degree is odd, the leading coefficient is positive. Now I want to point something out here in this last example. We actually don't have to open the brackets to find the degree or the leading coefficient. If we go back to this one here, I could have seen by looking at these powers of x, or these exponents here, when I take the first one, if I look at that 2, if I open this bracket, I know that the highest power is going to be x squared, and that x squared is going to have to multiply x cubed to give me x to the power of 5. I also could see that this 2 would be multiplying the 1 x squared, giving me a leading coefficient of 2. So first of all, I see that I have positive integer exponents, so I know this is a polynomial. Can you determine, without opening the brackets, the degree and the leading coefficient? When you open this bracket, I hope you see that you're going to have a positive x squared as the highest power of x in that bracket. When I open this bracket, I'm going to have a negative x cubed as the highest power of x. When we multiply the x squared and the x cubed, it gives me my degree of 5. When I'm looking for the leading coefficient, I see that I'm multiplying 3 times 1 times -1 to give me a -3 as the leading coefficient. You will want to practice finding the degree and the leading coefficient because it's going to be important as we move forward and look at graphing polynomial functions. We say that the graph of a polynomial function is smooth and continuous. Remember when we were looking at those graphs of piecewise defined functions, they were discontinuous, like this one here is discontinuous. It has a jump. You have to lift your pencil. So this one is not a polynomial function. But this one, the first example is, it's smooth, it's continuous. There are no sharp corners. I don't have to lift my pencil. Yes, this one is a polynomial function. What about the last two? And let's just say about this one here, it just didn't fit on the graph. It finishes up there. The first one, no, it's not. It is not smooth. It has this sharp vertex, not a polynomial function. This one, yeah, it is. It's smooth, it's continuous. You never have to lift your pencil. So that first one and the last one, those are the kinds of graphs we want to be doing as we look at the properties of polynomial functions.